It's 8:47 in the morning. You grab your keys, and something shifts in the room. Your dog's ears move before you've said a word. They've been tracking you for the last 20 minutes. The shoes going on, the coffee cup rinsed, the specific way you check your phone before leaving. By the time your hand touches the door handle, their heart rate has already changed. You haven't left yet, but their brain knows what's coming. Most people think their dog is just being dramatic, maybe a little needy. You feel slightly guilty, say, "Be good," and close the door. And then you assume they settle down, find a patch of sun, and wait. Here's what's actually happening on the other side of that door. For decades, the assumption was that dogs experience something mild when left alone. A low-level restlessness, maybe. The behaviorist framing was simple. Dogs are social animals. They prefer company. Absence causes some stress, and they habituate over time. That was the working model. It shaped training advice, it shaped veterinary guidelines, and most dog owners still believe some version of it today. The research tells a completely different story, and the gap between what we assumed and what the data shows is one of the most striking things I've come across in studying this topic. I want to start with a study that fundamentally changed how researchers think about canine separation. In 2003, Janneke Zeifman and Cindy Hazan at Cornell University had already established what's called the attachment behavioral system in humans, the neurological architecture that governs how we respond to separation from a primary caregiver. The key insight was this: true attachment isn't just preference. It's a specific biological system with 4 observable markers. You seek proximity to a specific individual. You use them as a safe base for exploring the world. You protest when separated. And you turn to them specifically when frightened or distressed. The question researchers started asking around the same time was whether dogs show the same 4 markers. Not just some of them, but all 4, specifically with their owner, and not with strangers or familiar people. Researchers at Eötvös Loránd University in Budapest took that question and built an experiment around it. They adapted Ainsworth's strange situation procedure, originally designed to classify attachment in human infants, and applied it to adult dogs with their owners. The setup is simple. You bring the dog into an unfamiliar room. The owner sits, the dog explores. Then the owner leaves. A stranger enters. The owner returns. You measure what happens at each transition. What they found stopped the field. When the owner left, the dog showed immediate, measurable distress. Not generalized anxiety, not a response to the unfamiliar room, but specifically owner-directed protest behavior. When the stranger was present, exploration dropped. When the owner returned, the dog sought contact specifically with the owner, not the stranger, even when the stranger had been present longer and had offered interaction. 61% of dogs tested were classified as securely attached. That number is almost identical to the proportion found in studies of human toddlers. Your dog doesn't just prefer you. They are attached to you in the clinical, neurological, measurable sense of that word. The same system that governs how a 2-year-old responds when their mother walks out of a room. But here's where it gets really interesting, because knowing the behavioral system is one thing. What's happening inside the brain is something else entirely. Gregory Berns at Emory University spent years doing something that most people thought was impossible. Putting dogs in an fMRI scanner, awake and unrestrained, and measuring their neural responses to specific stimuli. The training alone took months. The dogs had to learn to hold perfectly still inside a loud enclosed machine, voluntarily, with no sedation. Most of them did it. What Berns found when he introduced separation-related cues, the owner's scent, audio recordings of the owner's voice, objects associated with departure, was a consistent pattern of activation in the caudate nucleus. This is a region deep in the brain, part of the reward circuitry, associated in both dogs and humans with anticipation, motivation, and the processing of meaningful social stimuli. When your dog hears the specific sound of your keys, that region activates. Not because keys are interesting, because keys mean you're about to leave. Berns also identified that the caudate nucleus responds more strongly to owner-related cues than to stranger cues, food cues, or novel objects. Your dog's brain has built a dedicated anticipatory response to you specifically, and that response is active well before you've opened the door. Now, I want to tell you about a study that almost nobody in the general pet space talks about, because the finding seems almost too specific to be true. In 2019, a team at the University of Lincoln in the UK used heart rate variability monitoring, HRV, to measure physiological stress in dogs during owner absence. HRV is a measurement of the variation between heartbeats, and it's one of the most sensitive physiological markers we have for autonomic nervous system activation, meaning the branch of the nervous system that governs the stress response. The dogs were left alone for varying durations, 15 minutes, an hour, 4 hours. HRV dropped measurably within the first 3 to 4 minutes of the owner leaving, not after 30 minutes. Not when the dog realized the owner wasn't coming back quickly, within 3 to 4 minutes. But here's the part that surprised me. They also measured what happened when the owner returned after varying durations. Dogs left for 15 minutes showed HRV recovery within 5 to 6 minutes of reunion. Dogs left for 4 hours took significantly longer, sometimes over an hour, to return to baseline. The stress response wasn't just bigger with longer absence, it accumulated differently. The nervous system needed more time to regulate after longer separation. And they included a control condition. A familiar person who was not the owner stayed with the dog instead. HRV still dropped when the owner left. The familiar person did not prevent the physiological stress response. This wasn't about being alone. It was specifically about the owner's absence. Think about what that means for your dog. Every morning, when you leave for work, that stress response activates within minutes. The nervous system that governs heart rate, digestion, immune function, and the body's basic regulatory systems shifts into a measurably elevated state. For most dogs, in most households, this happens 5 days a week, for years. Here's a question almost nobody thinks to ask. Does this change over time? Do dogs habituate? Do they learn that the owner comes back? And does that learning eventually dampen the response? Some do. Dogs classified as securely attached in the Ainsworth procedure tend to show lower peak stress responses and faster recovery over time. The attachment system seems to regulate itself more efficiently when the bond is stable and the owner is reliably responsive. Dogs classified as insecurely attached, particularly those with anxious attachment styles, show higher peak responses and slower recovery. And these patterns tend to be stable rather than improving with time. What predicts which category your dog falls into? The research points to several factors. Early socialization matters. The consistency of the owner's responsiveness during the first year matters. And there's emerging genetic evidence. A 2021 study published in Scientific Reports identified variants in the melanocortin receptor gene, MC2R, that are associated with elevated cortisol responses to social separation in dogs. Some dogs are neurologically predisposed to more intense separation responses, and no amount of habituation fully overrides the underlying biology. Cortisol is the other piece of this. A 2015 study at the University of Veterinary Medicine, Vienna, measured salivary cortisol in dogs before and after owner departure. Cortisol, the primary stress hormone in both dogs and humans, rose significantly within 15 minutes of the owner leaving, and remained elevated for up to 30 minutes, even after the dog had visibly stopped showing behavioral signs of distress. The behavior resolved before the physiology did. Your dog might look calm. Their cortisol might still be elevated. This is one of the most practically important findings in this area, and it's almost never communicated to dog owners. What you see from the outside, your dog lying down, not barking, apparently settled, may not reflect what's happening internally. The nervous system is still working through the stress response after the outward behavior has subsided. So what does this mean for you and your dog in practical terms? The first thing it changes is how you think about the departure itself. The research on cortisol and HRV suggests that long, drawn-out goodbyes with elevated emotional tone actually prime the stress response. The owner's own physiological arousal is detectable to the dog through scent and body language, and it amplifies the anticipatory activation in the caudate nucleus. Short, calm, matter-of-fact departures are physiologically kinder. Not cold, not rushed to the point of anxiety, just calm. The second thing, the return matters more than most people realize. The HRV data shows that the reunion is a key regulatory moment. How you come home, your tone, your level of excitement, whether you immediately engage with your dog or spend 5 minutes catching up with your phone, affects how quickly the stress response resolves. And the third, if your dog's behavior around departures has changed. If a dog who previously settled quickly now paces, vocalizes, or shows signs of distress for longer, that shift is worth paying attention to. Behavioral changes around separation can be the first signal of increased baseline stress, physical discomfort that makes being alone harder to tolerate, or a change in the attachment dynamic. Behavior is the only channel your dog has to communicate with you. A shift in their departure behavior is a message worth reading carefully. Every morning when you leave, your dog's caudate nucleus activates in anticipation. Their heart rate variability drops within minutes. Their cortisol rises, and they wait, not passively, not comfortably, but with a stress response that is specific to your absence, measurable in their physiology, and grounded in the same attachment system that governs how a human infant responds to losing sight of their caregiver. The next time you put your hand on that door handle and see your dog's ears move, remember what's actually happening. 15,000 years of evolution built an attachment system so specific, so deeply wired, that your dog's body begins responding to the cues of your departure before you've moved a single step. That's not neediness. That's not drama. That's one of the most sophisticated social bonds in the animal kingdom, and it's pointed entirely at you. If this changed how you think about those morning goodbyes, subscribe to this channel and tell me in the comments, how long does your dog take to settle after you leave? I genuinely want to know. And if you want to understand what happens in your dog's brain when they stare at you across the room like they're reading your mind, that's the next video. The neuroscience behind that one is even stranger than you'd expect.